Let's now shift and talk about the idea of doing an incremental update or an incremental load with integration services. Now we're going to split this off kind of like we've done with the past few into several videos. We're going to do a couple that are lecture based and then a couple that are more demo based where we actually create the package and talk about how it all works here. Let's just make sure that everybody understands what an incremental update is. So let's go here to the next page. You'll see this called incremental loads. You'll see it calling just copying over the changes. The idea here is that you have a destination and a source that need to be in sync. So at the end of running your SSIS package, the source and the destination need to have the same data. And the easy ways to do that would be delete all of the rows at the destination and then simply copy over all of the source, right? I mean, that would be the easiest way. Just delete the source data and then copy everything from the source. Would that satisfy the requirements? I mean, would we be able to have everything in the same at the end of that process? Yeah, sure. However, that really only is going to work when you're dealing with small sets of data. If we're dealing with 100,000 rows, we could probably get something like that done in under 5 minutes or less. But if we're dealing with 50 million rows, 100 million rows, a data warehouse that has terabytes worth of data, this is not really possible. So an incremental load then becomes the way to load the data warehouse. You load your data warehouse using an incremental update. You load your relational data warehouse. You load, it doesn't have to be a data warehouse. This could be just a regular transactional database, could be a reporting database. But the idea is that you are just doing the changes since the last load. And so that's really what I've kind of put in quotes here, only the changes since the last load. And when I say load, what I mean is the last time you ran this package. So if you run this once a day, then you are strictly copying over the changes that have occurred during that 24-hour period. Okay? So that's the idea of what an incremental load is, an incremental update. And we often deal with the idea of a delta, which you'll often see abbreviated with a little triangle, to show that we just want the changes. That's really all we're dealing with here. Now, there's going to be at least one of the following, if not all of the following, could be any combination of the above. So we're talking about at the destination, we want to add any new rows that have been added at the source. So if again, we're synchronizing once a day, we want to add any rows that in the past 24 hours have been added to the source. We want those added to the destination as new rows. Now, I did abbreviate STLL, and that's just my abbreviation. That is not an abbreviation that you would see in the real world. I just meant it to be since the last load, just for shortcut here. One of the other options we could do is update the changed rows. So for example, if a user updates a source row to update their first name, to change their last name, to give themselves a new phone number, we want the destination to have that new phone number, to have those new names. So that would be an update. And then a delete, if we delete it at the source, do we also want to delete this at the destination? So we can do any combination of these. We could just strictly only do inserts. We could do inserts and updates only, or we can do all three. So it's really up to your business rules. I can't tell you how everybody else does it because each organization is different. You may want to do all three. You may have a business requirement that says you only want to add and update rows. You may perform what we call ghost deletes. So if you've never heard of a ghost delete, let me just come down here and, sorry, I can't get my pen to come down here. So a ghost delete is when you have a column in a row that marks it as not available for public consumption. You don't really delete the row. You use a marker, and that's my word. I don't know the technical term really, in the table that specifies that this row is not publicly visible. We could do a whole section on dealing with ghost deletes here, but the idea is that many organizations are not allowed to actually delete rows. And so they put a column in a table like is active. And it's just a Boolean, it's true, false. If it's an active record that users can see in the applications or in reporting, it has a value of true. If it's been a deleted record or it's a row that users are not allowed to see, then it would have a value of false. And so instead of allowing the application to delete a record, we would then mark that from true to false. Okay? But that would then become an update at the destination instead of a true delete. Okay, so these are all areas that you have to deal with when you're working with an incremental load. You've got to make decisions up front, and then you've got to follow through with SSIS. And sometimes you don't get to make these decisions. Sometimes they're passed down to you by a business requirement, a law. Some government organization has now decreed that this must happen. And so you just kind of have to define the framework or the process in which it works. Now, the adding of new rows can actually be a fairly simple process. For example, you guys probably, most of us are familiar with an identity column. I wrote it here as an auto incrementing primary key, and I ran off my little tablet, sorry. But on an identity column, you put in the first row and it automatically gets the number 1, and you add a second row, it automatically gets assigned the number 2, right? So those are actually fairly easy to work with because you can go to the destination and say, hey, what's the last identity value? What's the last primary key value that you loaded? And then you can go back to the source and say, give me every row that has a primary key value larger than this value here. So that's actually not difficult to do given an identity column primary key, which those are, at least in the SQL Server and Oracle worlds, those are pretty ubiquitous in the data warehousing world. You'll find lots and lots of those because they're just arbitrary numbers. They're really easy to work with. You could also use if you can get away with it, you could use a not exists or a not in query. So you could basically say, give me all of the records in this source whose primary key is not found in the set at the destination. That's probably going to be a more intense query because now you have to compare 200 million row tables, and that can, or column data indexes, clustered indexes, whatever it chooses to use. That can actually get pretty intense. So, that's definitely one way that we could do it, but just one way. Deleting rows can actually be fairly easy. It's just the flip side of what we just talked about. Delete all the rows at the destination that are not found in the source. Okay, not too challenging there. Updating the column data tends to be the more difficult of the 3 requirements. So you kind of have to make a choice here. Let's say that you know that a row has been updated. Which columns have been updated? All of them? Some of them? What's your plan? Are you going to have some very complex procedure that only finds out which columns were modified and you just keep those in sync? Or are you just going to say, I'm going to update the entire row? What else I've seen? I've also seen deleting the row at the destination and simply doing another insert. So you don't, in that particular case, you don't care what the old value of the row is. You don't care about trying to figure out which column changed. You're deleting the destination row and replacing it with the current copy of the source row. Your choice. You've got to make these decisions when you're dealing with an incremental load. Now, whatever operations you have to perform, adding, updating, deleting, you still have to have some type of a marker that identifies which rows have changed. Okay, so we talked about in the adding new rows about if you're dealing with an auto incrementing primary key, perhaps that's a way to do it. We talked about using not in and not exists, right? The primary key in those cases would be our marker to tell us what's been changed, what's been added, for example. And for a delete, this was actually pretty simple because we could say, hey, delete all rows in the destination who don't have a primary key value in the set of primary keys from the source. Okay. Uh, However, there are probably more efficient ways of doing this. And to deal with the update requirement, you must have some way of tracking which rows have changed. So let's talk about the techniques that we usually see. So the design patterns that most people use are listed here on page 9. So there's three main techniques that I have seen. Are there more? And undoubtedly. These are probably the three most popular in the SQL Server space that I've seen. Number one would be having some type of a column whose sole job is to tell you whether or not this is a new row, an updated row, a deleted row, or that the row hasn't changed at all. I'll show you an example here on the next page. Another technique that a lot of people use already for auditing purposes would be having some type of a column that is a date time based or date time to based column that says the last time this row was modified. So often I see these as being called last modified or modified date. Those are the names of the columns. And you'll have a trigger that anytime an update or an insert occurs, that then runs against that to update that last modified or modified date column. Those are actually pretty common as well. And then in SQL Server 2008, we have this new feature called Change Data Capture. So let's take a look at each one of these. We've kind of run out of time in this particular video. Let's coming back in the next video and take a look at these